Hey everybody, this is Larry. This is day 15 of the August Leetcode Daily Challenge. And we have a weekly challenge too. Hit the like button, hit the subscribe button, join me on Discord. Ooh, what am I doing? Let me know what you think about today's problem. 86 partition list. Given a head of a linked list partition so that all nodes less than X come before and after, you should preserve the original relative order. Alright, this seems pretty straightforward. It's another linked list problem, which I am not super strong with, to be honest, because I think other than what is it called least recently used LRU cache. Other than LRU cache, I feel like I don't really use it at all in real life. I think there was an advent of code problem at some point that was kind of fun to use. It didn't occur to me, but other than that, it really comes off very rarely. But in any case, doesn't mean we shouldn't try it. So let's give it a go. So yeah, let's say we have left head and left center node and a right center node just for before and after. Let's say I always call it new head because I don't know, naming is hard. So technically I guess I can do set this head right and then curve using a new head, and then yeah, what am I doing? Oh, I think technically what I want is left head and right head, and then I actually want left and right, but and then yeah, while current.next is not none, then we just partition it. So if current.next dot value is less than x, then we put it to the left. Was it next is equal to new node, or I guess I don't need to do the new node, right? So yeah, so current.next left is equal to left.next. In theory, this would, yeah, and then now we just reset it afterwards, right? Something like this. Same for the other side, a little bit of a symmetry, and then current.next. Maybe I did this in the wrong order actually, because then now this would be, yeah, okay. So actually, but the thing that we can do is do something like naming things is tough. .next is equal to none, and then yeah, because we have to set it to none. I mean, we don't have to because technically it gets modified next. But I don't know, it just feels cleaner to kind of it feels clean in the sense that now you have a loop invariant that the .next is none, so that you don't have to worry about it in edge cases. But yeah, and then now at the very end, left.next is equal to right head.next, and then now we can return new head.next. There's a lot of stuff going on, but hopefully this is right. And apparently I returned nothing, so oh, I guess I don't use new head. Oh, new head does, obviously this is not right. Whoops, I meant left.next, because we actually can't destroy this. So yeah. Okay, well, I mean, maybe did I mess everything up? And this is very easy to mess up, apparently. Why is it only a 4? It's the last element before we do it, so maybe something like that. But let's see if we can print it out, left and then right. There must be a silly mistake somewhere. So the oh, I meant left head. I was a little confused. Oh yeah, and then in this case, that's why it's messed up. I just can't. That's like the second time I returned the wrong thing. First time I just returned it. I meant left head. Okay, So what is the period again? Doing? Yeah, so did I mess up the right side? Why did the left side seems okay, but the right side, maybe I didn't pay attention to it too much. I think I could have run this a little bit differently, but why am I messing? No, this one's just silly. Okay, fine. But why are we not adding 2, 4, 3, and 5? And I talk all this stuff, and then apparently I still make silly mistakes somewhere. The hard part for me here right now, to be honest, is that I don't know how the left side can be working, but not the right side, because the code is so symmetric. I mean, other than having silly mistakes somewhere, obviously. Yeah, I mean, I guess I just have to. Oops. Oh no, I think I print out right and not right head, maybe? I don't know. Let's take a look at that actually. I don't remember what I print out. Okay, no, that's still wrong. But why? Tell me why. So 4, 3, 5. Oh no, that's. I don't know what this is actually. Oh well. The reason why this looks awkward is because we add the node, but we don't set it to none. I thought that's what this part would do. Okay. I think I did this a little bit wrong with the invariant, a little bit imprecise. Because okay, I see what I'm doing wrong. Because right now I mixed kind of ideas here. Because the idea here is that I'm only modifying next. There's 2 schools of thought about linked lists, and sometimes I mix them, or like usually not within the same form, but apparently I did this time. Is that you can either do modification on the current node or always do modification on the next node. Here I try to do it on only the next node, which is why I do that next and all these things. But then now I modify when I try to do it, because this should be something like current.next is equal to none or something like this, so that, because then what that it does is that it sets the thing that we just added to here to none. But I think I usually don't do it this way because I think it's too unnecessary. But I think that okay, fine. Let's just do it the other way, because then this is less stateful. Yeah. I guess technically I didn't need to write it like this, but like I could have written it like this. And then that's, then you don't even have to remove it. It does make it easier, but I was trying to be like, use the original memory. But I mean, it's better to have code that works than prettier optimized code that doesn't work, right? So anyway, this is linear time, linear space. You could maybe do it with all of one extra space. if I had done it correctly. I don't know. I mean, it's not impossible to do it correctly. It's just a lot of edge cases, and I'm kind of lazy today. Yeah. That's all I have for this one. Let me know what you think. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.